Sunny systems. Platform.
Okay. The color scheme's a bit off, so it's going to be a bit weird, but we'll make do. So before I start, I first of all want to thank very much Sunny Systems. Thank you for hosting me. Been very nice. And thank you to Nubank for this place. I want to tell you a bit about myself before I talk about Baseshift. Why did I create Baseshift? And why do I care about databases? Not many people care about databases, right? So my background is as a DBA. I have been a DBA for about 25 years. No, that's better. I started as an Oracle DBA about 26 years ago. And long story short, the last 10, 15 years, I have been a MySQL, Mongo, Postgres DBA. I typically would join companies or freelance for companies that are startups that were bought by bigger companies. And now the code that someone wrote at 10 o'clock at night actually has to work at scale. And of course, at first it doesn't. So that's what I would do for a few years. And something I've learned about having a database and being responsible for a database is that slowly over time you begin to have anxiety, database anxiety. I think in Portuguese you say ansiedade. Yes? Good. Database anxiety. Why do we have database anxiety? Where does this come from? Raise your hand if it was you who woke up in the middle of the night or on the weekend to fix a database problem. Okay, that's why. People write code, they push to production. They don't ask us, right? But they call us when it's not working, right? So we have fear. We have no control over this event, but we're the ones they call. So what do we do to stop this? How do we? What's our first move? The first thing we tend to do when we come to a company is we say, let's create an environment. We'll create staging, we'll create a dev system, preview environment. There's many names for this, but we take some data from production and we say, here, play with this first, make sure you know what you're doing, and then push to production. And hopefully it'll be okay, right? Well, this worked for a while. Up to maybe 5 years ago, that was fine. But now, people are pushing to production many times a day. Again and again and again. And all we've given them is one staging system, right? This doesn't work well over time. Because when you have a team of 6 to 10 developers, pretty small, you already begin to have problems. So let's just say you're using shared environments, and one developer says, oh, you know, I need a fresh update of staging. Please press the button or run whatever you have to run. And then developer 2 says, no, 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 I'm debugging, right? And then developer 3 says, who broke my staging? I need to test stuff, right? And it's, of course, us, DBAs, DBREs, platform engineers. It's our problem, right? We have to write the scripts and fix it. It's obvious that whatever we've been doing until now, it doesn't hold water. Not anymore. And it definitely won't hold water with AI, right? People are writing a lot more code with AI. And just for a show of hands, who here has teams writing code with AI? Like Claude Code, Codex, Cursor, Windsurf, whatever it is they like, they use, right? So everyone's writing code with AI. The AI needs an environment, and we have to supply these environments. Now, one other question. How many of you are confident that someone's reading all this code that AI is writing? That's what I thought. Nobody's reading the code, right? The same people you were afraid of giving access to production are pushing code they haven't even read into production. Doesn't sound good for the database. AI, especially coding with AI, creates new problems. First of all, AI likes to make rapid changes and like go one way and say, oops, and then go backwards and try something else, right? So we have to have some infrastructure that lets the AI run at its pace. But like we just saw, nobody's reading all this code. It's a bit scary. At the very least, we want to know what is the AI doing to the database. Like a shadow. What is the shadow of the operation on the database? What table is it creating? What index is it modifying? What queries is it modifying? And of course, we also want to know how is this going to impact the database, right? It's not enough to know, yes, it's creating a table. Yes, it's creating an index. Yes, it's creating a query. Because all the tests can pass. And when you roll out to production, you'll still be surprised. When you think of how many agents and how much code a single developer is about to write, and you multiply that by 5 to 10 developers, it becomes a torrent. An amount of code that is just insurmountable. No one's reading this. No one can think about it. Even if someone read it, there's no way they would figure out how it's going to impact the database. And of course, sometimes AI just goes crazy. And I mean, how many of you have seen something like this? Right? AI just wakes up one day and says, yes, let me deploy to production and delete everything. Or let me drop your database for fun. So clearly, we have to do something. What are we going to do? So we understand that we need a new foundation. Have you guys heard the term hyperengineering? Anybody heard of this term? We need to start building systems that build systems, right? A code factory for a code factory. And there's a lot of components. One of those components is the database. We need to find a way to supply the agents like an automated machine. Supply them with data, fresh data, compliant data. We need to be able to do this at scale for cheap and quickly. So let's go back a bit. You've all had to create a copy for someone because you've always got that Slack request at the worst possible time. Hey, do me a favor, make another copy of the database for me. It's never just a copy, right? It's never just, please press the button in AWS. It's always, okay, we need 500 of these because we have 500 developers. Or it's, I don't need it in production, I need it in the other region because that's where the developers are, right? It's always, I don't want it in RDS, I need it connected to Kubernetes so that my developer environments can start. And even if you got the scale and you have the money, and even if you figured out how to copy the snapshots and all that, now you have compliance. CISO calls you up and says, hey man, I heard you're giving people connections to production data. No go, no good. Start writing scripts, updating scripts. So you fix that. And your database grows, and it's 1 terabyte, 2 terabyte. And now it takes 8, 10, 24 hours from the moment you get that Slack request until that database is ready. And everyone's asking you, when's it going to be ready? Why isn't it ready? So it's never just a copy. It's a whole problem. This is why we built Baseshift. Baseshift is an end-to-end, all batteries included solution to this problem. Baseshift will connect to your source database, map out where is the sensitive data, make a copy. While it copies, it will sanitize data, anonymization, subsetting, whatever it is that you guys need to do. We then create snapshots. We'll talk about that in a second. We take these snapshots and we provide them, we let you provide them to whoever needs it in the business. If it's developers, their agents, if it's CI/CD, if it's salespeople who call you up and say, hey man, I have a new customer tomorrow. Can you do me a favor and make a copy for me? But we go even further. You have to now manage these environments. You might have hundreds. How do you manage them? Developers like to kind of start environments and go home, forget about them. And you're printing money for Amazon. They're building houses because this developer didn't close his environment, right? And you have to create environments for a CI/CD, and you have to set them up in different region. It's a whole thing. So Baseshift solves all of this for you. One product for multiple database types, Postgres, MySQL, right? Postgres, MySQL, Mongo. Soon we're going to have SQL Server, Elasticsearch, whatever you guys need. Let's take a look at how this works. Baseshift is mostly software that you install in your cloud. We don't want to see your data, it's your data. We have two components. One is a server and one is an agent. The server comes clean and then installs the database of your choice. So Postgres if you're on Postgres, MySQL if you're on MySQL, you get it? We download and install the regular database binary anyone would install off the internet. Same thing as apt install Postgres, apt install MySQL. It's not a fork, it's regular database. Then we connect from the masked replica, that's the instance of the database, to the source DB. It could be usually some RDS, it can be the master, it can be the read replica. And we start making a copy. We make our first copy. Now here's where things get very different at Baseshift. Typically, what you guys see is you first make a copy and then start anonymizing, right? That's the move. You do RDS snapshot, you create restore from backup, you start doing updates, deletes, whatever, and you wait until it's done. We do an inversion of the process. As the data comes out of the source DB and finds its way to our instance, we modify the packets in real time. So when we start pulling data out, as it's moving, it goes through our proxy, we open up the packets, modify the data, close the packets. When you load the data, it's already anonymized. But again, we go one step further, and we say, you don't want to copy everything every time you want a snapshot. Let's use deltas. You guys are familiar with replication, the various types? So we use replication, and we connect to the source DB and start getting deltas. Again, the deltas go through the scrubber, scrub PII. So you can think of our instance as like a read replica, because it does replicate from the source, but it's already anonymized. And that's pretty cool, right? Because now I can create snapshots. And the snapshots are already anonymized. And if the snapshot's anonymized, when I start up a clone, it's immediately available. But we go one step further. Our snapshots are nothing like anything you've seen before. We are not RDS snapshots. We don't create EBS snapshots. We don't create EFS snapshots. Much simpler. We create files. Think of just a directory with a whole bunch of files. You can zip it, you can tar-gz it, you can put it in S3, you can put it on a USB drive. You get it, files. We take these files and we let you run clones over them, just like you create lightweight clones in RDS. But you can do many things with files that you can't do otherwise. For example, we can take all these files, create a Docker image, put it in ECR, Artifactory, whatever you guys use, and now you have a Dockerized version of your database, anonymized, and you can just pull it into Kubernetes or locally to a computer. You can move it between regions. You can move it between accounts. Pretty simple. One other thing we do is we let you run clones directly over the snapshots in the server. And you can run dozens, even hundreds of clones in the server. I'll show you a demo, you'll see how it works. But the point is, we free your data. You're no longer stuck with snapshots inside the cloud. It's a Docker image. It's files. Literally, put them in S3, download them to somewhere else, transfer them, whatever you want. Let's visualize this. Say you have a 1 terabyte database in RDS, and you want to create a snapshot. Like I said, we pull it out, we go through our scrubber, we have it anonymized, it lands in the server, and the server creates the first snapshot. Our snapshots are compressed, typically about 1:3, 1:4 ratio. So the snapshot of 1 terabyte becomes 300 gigabytes as either a Docker image or just a bunch of files. So you create your first snapshot, but a day has passed. Over the course of a day, the database changes. It's a little bit different from what it was yesterday. And the developer wants the latest snapshot. You don't want to copy the whole terabyte again, right? So we let you do the delta. We detect what has changed at the bit level from the base snapshot to the new snapshot after 24 hours. And we again encode these as delta files. And you can do whatever you want with these delta files. It's just a directory with files. We can create another layer in a Docker image. You can download the delta by doing Docker pull. Everything one would do with Docker. This is very convenient because it acts like, not exactly like, but similar to Git. It's a trunk of commits. It's a trunk of commits. You can branch off of any point in history, and you can create as many clones as you like, very quickly and for cheap. The clones, the writable clones, the writable Postgres instances, they don't see each other. They share the snapshot data, and they take space in proportion to how many changes the developer makes, or the agent, right? You can have on one server over 100 clones, easily, or 100 environments for agents. So what are some of the benefits of our technology? First of all, everything we do is Dockerized. All of our components are Dockerized, and we can let you install it in whatever environment you're using. If it's in AWS, we have CloudFormation. If you have your own Kubernetes, we have Helm charts, Terraform, whatever blows your bubble. We are security first, and as you've noticed, the data stays in your network. I will add on that all the files we create are encrypted, AES, XTS, I think 256-bit, so you guys have keys to the files that we don't see. Furthermore, we create a lot of reduction in cost because we reduce in 2 dimensions. We reduce in the dimension of compression, so instead of 1 terabyte, you'll get 300 gigs, but we also do deltas. And so we see, that's conservative, we see 90-95% reduction in cost. Actually, what we see is it's so much cheaper to do this with Baseshift that suddenly you can provide solutions to your developer teams that you wouldn't have done otherwise just because it was too expensive. Like, I just met a company earlier today who has over 1,000 developers. How are you going to make 1,000 copies, right? The math doesn't math. Because let's say you're spending $100K on an RDS instance, and you can create a developer instance for 1/100th the cost, right? So $1,000 instead of $100,000. If you have 1,000 developers, that's $1 million. You're paying 10 times more for the RDS of the developers than you are for production. And let me guess, nobody's going to sign off on that, right? So you have to go back to the developers and say, nope, sorry, you can't do it. Fourth, we create clones however it is you like. We can create Docker images. We can run clones inside our server. We can just take files and give them to you, and you can move them around. Feel free. Fifth, like I said before, we support many databases. But why do we do this? Raise your hand if your production environment has more than one type of database. Right? You have Postgres Mongo, Postgres ClickHouse, MySQL Mongo, SQL Server ClickHouse, all these combinations. For a developer, they don't think in terms of databases, they think in terms of my production environment. For the app to start, I need 3 connection strings. I need Postgres, Mongo, Redis, maybe S3, right? We understand this first class. Our system understands that you have to think of 3 databases put together as one data environment. When you tell us to snapshot, we snapshot all 3 together and call it your environment. The developer wants a clone, he sends us a command, we give him 3 connection strings. So what does this look like when you add in AI? This becomes interesting. This is what developers are doing, right? They're not writing code, they're writing prompts. So they write the prompt, the agent starts up. I'm going to demo this, you're going to see this live. And the agent has their MCP or CLI, whatever they want to use, and they'll spin up a clone all by themselves. They'll run their code, they'll do their migration, start playing with the code, run the tests, come back, something isn't working, shut down the clone, start up the clone, do their own thing. They sit there for hours, going in circles. Eventually, the agent says, I'm done. It created 7 clones without any human interference, no DevOps. No one's calling you guys, right? It just does all by itself. And in the end, we will tell you, your developers or you, what did the AI do with the clone. And I'm going to demo that in a moment. So let's take a look. Now, I will say, this is going to be a live demo. This is not a video. Things might not go right, okay? So give me a break. How do let me see. I'm going to try to, I want it to be mirror, yeah, not extend. Mirror, yeah. Perfect. Okay, so we're going to start with, where is it? That's why. Here's the app. Can you guys see okay? I think that's a bit small. How's that? Is that good enough? Is that okay? So in Baseshift, we have an object called a dub. A dub is your source database plus some masking policy or subsetting policy plus some schedule for creating snapshots. And you can have multiple dubs for the same database. So you can have one dub that creates a small Docker image that developers can download, and another dub for the same database that grabs the entire database, doesn't mask it, but no one has permissions to it but the CI. That's why we call it a dub. So here's a demo dub of a very small database, 1 gig, just for the purposes of the demo. And you can access it, the clones of this dub, in 2 ways. One is pretty trivial. You press this button, a bunch of commands, authenticate, Docker pull, Docker run, you have a database. The second thing is a clone. Now what I want you to notice is how quickly the clone launches. This is a real clone. This is actually happening. That was it. You see it? Try it again. That's it. That's a clone. Our server can run, and each one of these is a separate Postgres, separately writable. We can run hundreds of these on one server. You can do this via CLI, via MCP, via REST API. If you even want to, we'll give you a GraphQL endpoint. The point is, you can now create clones very quickly, at scale, for cheap, with multiple types of databases. This works for MySQL, for Mongo, etc. So let's first take a look. Well, I want to show you. This is a real clone. I'm going to shut them down. Let's start with our CLI. To save some time, I already authenticated. Let me find command. I set it up. This is the same command that you saw from the UI. Pretty simple. That's it. It's up. Now it's just making sure that there's a ping, and I can shut it down. You get the idea. This works inside a container. It works inside CI/CD. So you just do pip install Baseshift, set up the authentication tokens, Baseshift clone start. We'll give you a local port. We handle all the networking, so we can use things like Tailscale to jump the local port into our server. Saves you all that work with the firewall and the VPN. Makes life very easy. But what you really want is to support AI, right? Because who writes code today? So what we have is a demo. Now this is a truly live demo. This might not work. What we've done, you know what? I have to show you something first. What we've done is created an app from the well-known Acme HR database. Anybody here familiar with the Acme HR database? No? All right. You have to be an Oracle guy to know this. When you do trading in Oracle, they give you this fake database, and you can kind of play with SQL and learn how it works. So it's a pretty simple database. 6 tables, describes an HR system. What we've done is we've created a Python app just to kind of simulate a Django Python app where we can play with our tech. And we're going to give the AI a very simple task. We're going to tell the AI, you see that titles table? We want to normalize the titles, because that's a string. It's a very common task where you say, hey, we need to have a distinct list of titles, fix it. Happens all the time. So we're going to start this up, and it's going to take a while. And while it runs, I'm going to explain what's happening. The AI has our MCP. It's going to start up an instance. It's going to try to write a migration, and it's going to fail. It's going to fail because I've intentionally tricked it. What it's going to learn is that there's information in that table that is built to make it fail on its first naive attempt. Now, this is, of course, just construed just so you'll see the point. But the point is, in a real system, this happens daily. The developers or the AI try to make a naive attempt at a migration, And when it hits production, stuff happens that nobody thought about. Because the variations of data in production are so diverse that you can't possibly think of all the combinations. So you try, and either you succeed or you fail. But the point is, you want to let the AI try and fail by itself, right? You want to give the engineers the ability to just give a prompt, let the AI run in circles, try, fail, create a clone, drop a clone, without bothering you or anybody on your team. And that's what we're going to see in a second. So, let's take a look. So, the AI realized it needs to start a clone. That's what it did. It's using our MCP. This is the Baseshift MCP. It's just another parameter of our CLI. And it's running queries, and it's building. I think that this time, it decided to do something very convoluted. But we'll let it run. But the point is, I can create another agent. In fact, I can start up 5. Let's see. Right? That's what developers are doing. They're creating lots and lots of agents. And each one needs its own set of environments, its own set of clones. And that's what we enable. Right? Because the next step is hyper-engineering. The next step is it's not going to be on the developer's computer. It's going to be a service. The developers are just going to send a prompt, and it's going to run somewhere. And wherever it's running, it needs an environment. So one of the hardest problems here is how do you provide those agents with a database copy, a fresh, compliant, cheap, at-scale infrastructure for doing this. And that's what Baseshift is about. So it's going to run. And here we go. It already hit its first error. It's a pretty silly error. It'll get around it. Unfortunately, this is going to take a while. So I'm going to show you what happens when it succeeds. So one thing that's special about Baseshift is that we record everything done against the clone. When we give you a port, we're not giving you a port to the database. We're giving you a port to our proxy. And our proxy is recording everything that your app is sending, or the AI's code is sending to the clone. This is especially useful in CI/CD, because now we can open up the recorded queries and begin to see what is the AI doing. And we can come in here and we can say, okay, show me the create. And here it is, right? And once we have this, we can do things with it. First of all, we can give it to you. There's an API. You can grab it. You can put it into scripts. You can write your own scripts that say the table jobs or table titles. Can you see this well? I'm not sure you can see it so well. How's that? You can create your own scripts and protect the tables and the queries that you care about. Because some of your DBREs and DBAs will say, I don't care what the AI does, but don't touch the most important table, right? Or don't touch the dashboard query. Because you know what happens when the dashboard query gets slow, someone's getting a phone call, right? So we give you the transparency, what we call the shadow of the operation, in terms of the database, so that you have a lot of confidence now in being able to catch stuff that the AI is doing wrong without bothering the developer, right? So you're giving them what they need to work while giving yourself the power to protect the resources you care about. Now, finally, the last step in this thing is it is necessary to give sandboxes. It is necessary to know what the things are doing, but it is still insufficient to let you sleep at night, right? Because the test can pass, and this can pass, and you'll see all your data, but that's still not enough. You can still have a migration that takes a lock, goes to production, and oops, 3 hours, no transactions. That can happen. So what you really want is one more layer. You want a protective layer. You want something to look at all the changes, compare it to production, and just put something on the pull request that says, nope, get someone to look at this. Or another AI, I don't care, but this shall not pass, right? And that is what Baseshift is. Baseshift is an end-to-end, all batteries included solution for today's problems and tomorrow. Okay? So, obrigado. This is a QR code. It leads to a form. You can contact us or Sunny Systems, and we're happy to meet you and have a chat.
Thank you, Amir. Alguém tem alguma pergunta? Se quiser fazer em inglês, português, a gente pode.
Hello, hi. First of all, congrats for the technology. It's really awesome. But my question is, how likely, how fast is the delta calculated over some database after, let's say, tons of insertions, several insertions? Is it a likely process or it takes time?
It's instant because the inserts go into the database from the top, and our deltas are on the data files. So by the time we take a snapshot, it's just bits that have already been modified. We don't even know what the database is doing. We just monitor bits in the files. So when you ask us to start up a clone, we're just showing you the data as it is after the insert. Does that make sense?
Yeah, it makes total sense.
Yeah.
Thank you.
By the way, if you want to, if you have time, I can show you how all this works. I don't know if you care, but we have time, unless there's questions.
Yeah, one doubt. One of the key steps there is that you scrub the data to remove any PII data. Is it localized for all the, because I mean, some attributes, like in Brazil, for instance, you have, the keys that identify a citizen will vary a lot.
Yeah.
Is it localized? How do you handle this? I mean, to be able to identify what is a PII in whatever region you're running the solution?
That's a really good question. So we have two components. One is the PII detector, where it'll sample your source database, try to figure out what's what. It'll then present to you the suggested policy, and you can change it either in the UI or via API. And then you tell us what to do with the fields. At this time, the current version requires us to implement functions for you, but the next version, you'll be able to do it all by yourself. So you'll be able to give us the regex, and very soon, this is what I hope to do, is to have very simple neural classifiers that'll just try to figure out what kind of information it is, and then you can give us functions in Go, Python, whatever, and we'll just plug it in.
Yeah, it makes sense. Yeah,
Yeah.
great.
Thank you, Amir. I'm not a data engineer, but I already contribute with data ops with a data team. I was thinking about the medallation model or framework. Did you familiar with medallation framework? Bronze to silver, silver to gold, and so on
No, I'm sorry,
ETL?
I'm not familiar.
Okay.
I apologize.
Basically, browse layer, it's raw data that's ingested from the customer, from the BD data, and so on. The data is treated or manipulated, then go to the silver to finally go to the last layer of its production. It's gold, the last layer. So I was thinking about the sandbox environment to guarantee that our raw data in schema are safe. What underlying isolation mechanisms are you using for this sandbox? You mentioned that isolation is gave by, I can containerize it, but I am thinking, could it mess up the data on raw data on sandbox or no? What do you think about this isolation? It's totally, or if I am ingesting data from other source, could I mess it up it or no? Something like that.
I'm going to try to answer,
No
because I'm not sure I understood the question.
No, no problem. After we
if,
can.
if I
talk
understand the
more about-
question correctly, and correct me if I'm wrong, what you're asking is, once I have a snapshot, how can I make sure that I don't mess up data of other clones while I'm working on one clone?
Yes.
Yeah, okay. So, I think it's easiest to just show you under the hood how this all works. Is that something you want to see? Do we have time, Fabio? Okay. So by chance, I have prepared, because usually people ask. So, how does Baseshift work? Quick primer. I'm not sure if you guys are familiar with this, but most binaries, especially database binaries, don't talk directly to the kernel. This is true for all operating systems, Windows, Linux, Mac OS, FreeBSD. They typically have to use a library called libc, which converts calls that were generated in source code at the time of compilation into a kernel command. And this is kind of the oil between the kernel and the app. So kernel developers can make changes without changing a compiled app. This library is exposed by the operating system and then is in real time connected to the binary when the binary starts up and becomes a program. This is called dynamic linking. Right? It's a pretty familiar concept. You can read about it on Wikipedia. We do something called hooking, which means we interfere with this process. And we shove our libc instead of the operating system's libc. And by doing this, we can control how the I/O happens. And we do this in user space, meaning it has nothing to do with the kernel. The operating system has no idea this is happening. It's same thing for Windows, Mac, Linux. Same thing inside Docker, outside of Docker. It's very convenient because it's like giving you the ability to create deltas between snapshots, but without any driver, any file system, and yet it's the exact same binary one downloads off the internet. It's like adding magic powers to an existing database. Or as I like to say, we are teaching an old dog new tricks, right? So because we do it this way, every clone is basically just a process. It's a Postgres or MySQL instance. It has two legs. One leg points to read-only files. The other leg points to a directory of files for that specific clone. And this should answer your question, meaning every clone has its own directory. The integration of the snapshot, its deltas, and the clone happen in memory in real time. But it's separated by user space. It's two completely different programs. They don't know each other are running, right? And when you're in Docker, then you have completely different C groups. So you're completely separated in memory space. Right? So I hope that answers the question.
Last question.
Hi. First, congratulations. Very nice. My English is very bad, so maybe you talk about it. But when you clone a database and create a snapshot, you clone all database or some data, sanitize or
Whatever you give us a source connection string, and you point us at the database you want, and we start pulling data in. So it depends on you.
So how do you compress so much? And
So-
one terabyte to 300 gigabytes.
First of all, it's compression, so it's not consistent. And if it's encrypted data, then obviously I can't double compress or compress encrypted data. But we compress at the block level. Because again, we are in libc. We see every time the database sends information to store on a file, we see it, we interfere, we compress it, and then we write it into the file by ourselves. And we do the inverse when we read.
Nice. Thank you very much.
My pleasure. So I think that's it. So first of all, happy hours on us. First drink. Enjoy. And if that's
did it.
all, I think I have to run because I have to check out before they bill me. So thank you so much for waiting and for listening. If you want to chat and hang out, I'm happy to talk in the happy hour. And again, thank you to our wonderful hosts for a great conference.
Thank you, Amir.